right. This week we have been working on comparing fractions with different denominators and creating a common denominator. So today I'm going to do a short video on creating a common denominator using equivalent fractions. And I'm also going to introduce another strategy that we've been using in the classroom before we move on to our next and upcoming standards. All right, so here is a fraction that I pulled from our iReady book where the students had to compare 3/5 and 3/10. And over here to the right, if you look at the before, our fraction clearly has two different denominators. And that is when students have to go in and do some reasoning and problem solving to figure out how can we change the denominators so the denominators are the same. If the denominators are not the same, then we cannot compare the two fractions. So the best way to compare the two fractions is to first make sure that the denominators are the same. So we create a common denominator, and we can use equivalent fractions to help us do that. Now, looking at the denominators 5 and 10, a lot of our scholars might be able to recognize the relationship and identify automatically a common denominator. And if that's not the case, then I'll show you a strategy later in the video on how your scholar can identify the relationship. But usually our scholars are able to identify quickly the relationship between the denominators and figure out how to create a denominator because they know their math facts. So when I presented this problem to my scholars, they automatically knew that we could change 3/5 to have a common denominator as 10 by multiplying times 2. So over to the left, what we did was to create a common denominator, we multiplied our denominator times 2 to get a common denominator of 10. And the general rule that we introduce to students that whatever you do to the bottom, the denominator, you must do the same thing to the top, the numerator, to get an equivalent fraction. So once we multiplied our denominator times 2, on the bottom, we did the same thing on the top. And that gave us an equivalent fraction of 6/10. Well, I went over to change the fraction. So now that we found an equivalent fraction here, now we can take this equivalent fraction and compare it to our original fraction here, which was 3/10. So now we have two fractions that have a common denominator. We have 6/10 and we have 3/10. That makes it easier for us to compare because the denominators are referring to the same whole. They have the same denominator. And because our students have the prior knowledge, they know that 6 is greater than 3. So we go in and we revisit the problem and we compare using our greater than, less than, or equal to symbol. For this particular problem, we found that 6/10 was in fact greater than 3/10. So that means that 3/5 is also greater than 3/10. Okay. So that is what we do to compare. We use our prior knowledge of equivalent fractions to help us compare fractions easier. And that gives us the ability to look at the problem and say, okay, now that we have common denominators, we can easily compare those two fractions. All right, we're going to do another one on a separate slide, just in case I move too fast with that one. All right, so here is another problem where we have two fractions. If you look at the before, we have two fractions that do not have the same denominator. The denominator is different. So our students can do two things. They can quickly identify the relationship between 7 and 14 and figure out how can I change that fraction to have the same denominator, or they can do it what we call the old school way, and they can write out their multiples. LCM stands for least common multiple, and that helps us identify a common denominator that we could use. For our scholars that can't identify the relationship quickly, we can have them write out their multiples here. So I have my scholars to write out their multiples for 7 and for 14 to figure out what denominator do they have in common that we could use to solve this problem. Once they write out their multiples, they will find that they have 14 in common. So that will become our common denominator. So what we do is we take that 14 and we try to convert it. Now, 3 out of 14 already has a denominator of 14. So we don't need to change anything here. 3 14s can stay the same. What we need to do is change 2 7s because that denominator does not have a denominator of 14. So down here, what we did was we wrote out 2 7s. And what we wanted to do was convert that denominator 7 to a denominator of 14 so that 3 14s, they would have the same denominator. Well, the relationship between 7 and 14 is times 2. So the rule of thumb is whatever you do on the bottom, you must do the same thing on the top. So if we do times 2 on the bottom, we must do times 2 on the top. 7 times 2 is 14. So 2 times 2 gives us 4. Now we have a fraction that is equivalent to 2 7s, but this time around, our denominator is the same as 3 14s, which makes it easier for us to compare. Now moving to the after, here in the after, we find that 4 14s and 3 14s can be compared because the denominators are in fact the same. And from prior knowledge, we know that 4 is greater than 3. They're referring to the same whole. So 4 is greater than 3. So 4 14s is greater than 3 14s. Now, this is a concept that does take practice. It does take time. Once scholars get comfortable with identifying that common denominator, they'll be able to easily compare fractions at a faster rate. Now, I want to go over one more strategy that scholars will use to identify fractions at a faster rate, and this will give them the luxury to compare fractions using benchmark fractions. So let's talk about what benchmark fractions are. A benchmark fraction is a fraction that is equivalent to a whole or half. And benchmark fractions give us the reasoning to compare at a faster rate. So I pulled a problem from our already textbook, and it says that Sam's music teacher tells him to practice his trombone for 5/10 of an hour. Sam only practices for 2/6 of an hour. And the question says, does he practice long enough? Show your work. Well, we have two fractions that we're focusing on. We have 5/10 and we have 2/6. So those are the two fractions that we're going to be comparing for this particular strategy, which is using benchmark fractions. So I'm going to go and show you guys. A benchmark fraction is a fraction that is equivalent to 1/2 or 1/2. So I use my digital tools, and I have here, I'm going to get my pointer. Here I have 1/2. Okay. And then here I have 5/10, which is represented in the problem. That's how long he should have practiced his trombone. And then I have a fraction that is showing 2/6, which is how long he actually practiced. Now, students who understand benchmark fractions, they would see that, okay, 1/2 is here, 5/10 is equivalent to 1/2. So Sam's teacher wanted him to practice for half an hour. Okay. But if we look at 2/6, 2/6 is actually less than half. So that means that Sam practiced less than half an hour. And with that knowledge, knowing automatically that 5/10 is half, and knowing that 2/6 is less than half, students will be able to compare fractions quicker, faster, because they'll look at a fraction, identify the benchmark, and say, oh, that fraction is equivalent to half. But this fraction is actually less than half. So I know automatically that 5/10 is more than 2/6. And for this particular problem, the question asks us to compare, but the question says, does he practice long enough? Now, Sam practiced for 2/6 of an hour, which is less than half, and he was supposed to practice for half an hour. So that proves that Sam did not practice long enough. And for this particular strategy, I did not need to use scratch paper. I just needed to use mental reasoning to explain that 5/10 is equivalent to half, but 2/6 is not equivalent to half. It's less than half. So that means that Sam did not practice long enough on his trombone. So that one is benchmark fractions is more so a mental strategy. I suggest that students understand the strategy for testing purposes. Yes, they need to know the other strategies, LCM and using equivalent fractions to compare, but they also need to know that time is of the essence and our state tests are timed, and knowing different strategies will help them on the test. So I teach them to find the least common multiple if they need that. I also teach them to use equivalent fractions to compare. And we also want them to know the mental strategies, which is using a benchmark fraction to compare. Students who know which fractions are equivalent to half can easily compare fractions and say, oh, that fraction is less than the other based on the benchmark. So this is a strategy I want students to understand, along with finding the least common multiple and the common denominator. We will continue to practice these two strategies, but in the future, we are moving on. Coming up next on our standards and our agenda is basically adding and subtracting fractions. We are going to be decomposing fractions, and we're also going to go into geometry in the next couple of weeks. So it's important that students have mastered comparing fractions and equivalent fractions, because we're moving on next week and the upcoming weeks, and we're covering adding and subtracting fractions in geometry. So please make sure you're going over the homework, spiral reviewing with students. If students come home with any materials, please go over it with them. If need be, you can schedule a conference so we can talk about maybe utilizing laptops for already to continue seeing those skills at home. But parents, we stress that MOY is coming soon. So it's important that students have mastered their standards and consistently practicing at home over time. All right, so I have another video coming up soon where I will go over adding fractions and geometry, which will be posted in another 2 weeks. So please keep an eye out on that video as well. And I'll be in touch, and happy holidays.